Assalamualaikum and salam sejahtera. Today's video will be on functions, and we will be learning on how to find the domain and range from graphs of functions. So the content for today's lesson will be understanding what is domain and range of functions, and we will practice how to find the domain and range of the functions. Lastly, there will be a summary of today's lesson. So what is the domain and range of a function? Let's consider f a function that maps element of set x to set y. That is f such that x maps to y. Then the domain of the function f is the set of values of x for which the function is defined. In other words, domain refers to the set of possible inputs values. Range of the function is the set of possible values of y or f of f that f takes. Simple way of saying, the range is the set of possible output values. So how do we find the domain and range from a graph? Consider the graph of y equal f of x, which is defined for x between a and b, where the values of a and b are inclusive, and their respective values of y are c and d, where c and d are inclusive. Notice the small shaded circle on the curve. This indicates that the x and y values are included. Hence, the domain of f is the x values that range from a to b and can be written as in interval form square bracket a, b, or in set form x such that x lies between a and b, where a and b are inclusive. And the range of f is the values of y that range from c to d and can be written as range of f equal in interval form the square brackets indicating that c and d are inclusive, or in set form y is between c and d, where c and d are inclusive. Now, let's practice how to find the domain and range from a graph. Let's look at the first example. Given the graph of the quadratic function f of x equal x plus 2 squared, determine its domain and range. Here, the curve of the quadratic function continues beyond the portion of the graph we can see. The domain and range may be greater than the visible values. We can observe that the horizontal extent of the graph is for all values of x in the real number system R, so the domain is R, or written in set form x such that x belongs in R. The vertical extent of the graph starts from y equal 0, so the range of f is written as in interval form square bracket from 0 to infinity round bracket, or in set form f of x such that f of x is greater equal 0. For the second example, we are required to sketch the graph of the function h of x equals negative 2x minus 3 squared minus 1 and determine its domain and range. Remember how to sketch the graph of a quadratic function? Firstly, we need to identify the shape of the curve, whether it has minimum or maximum point. By looking at the value of a, here our a is -2, which is less than 0. Hence, the function h of x has a maximum point, which is 3, -1. This can be read from the function itself, as the function is in completing the square form. And the curve cuts the y-axis at the point 0, -19. Okay, now we can sketch our function. Here we have the x-axis and the y-axis labeled as h of x, and the maximum quadratic curve that passes through 0, -19 and 3, -1. Please take note that the graph continues beyond the portion of the graph that we see. The domain and range may be greater than the feasible values. Thus, the domain of h is all the values of x in R and written as dh equal R, or in set form x such that x belongs in R. And the range is from -infinity to the maximum value of y, which is -1. So the range is written as in interval form, round bracket -infinity to -1 square bracket. -1 is inclusive. Or in set form, h of x such that h of x is less than equal -1. In this example, we need to find the domain and range of the function gx, whose graph is shown below. Observe the small shaded circle on the curve, which indicates that the point -4, -12, and the point 18 are inclusive. Thus, the horizontal extent of the graph is from -4 to 1. So the domain is written as in interval form -4, 1 in the square brackets, or in set form x such that x lies between -4 and 1 inclusive. The vertical extent of the graph is from -12 to 8. So the range written in interval form is the square bracket -12, 8, or in set form y such that y lies between -12 and 8 inclusive. In this example, we are required to sketch the graph of the function f of x equal to over x and determine its domain and range. Before we do so, let us look at the characteristic of the reciprocal function. Now, the graph of the function will not intersect the line x equals 0, since the denominator or the bottom of the fraction cannot be 0. The graph will also not intersect the line y equals 0, since for large values of x, f of x tends to 0. These lines are known as the asymptotes of f of x. So in other words, the curve of the function will not touch or intersect the asymptotes. The shape of the graph of the function is an arc, which lies in the first and third quadrants, since the numerator of the function is of a positive value 2. Now we can sketch the graph of the function. First, we draw the x-axis, followed by the y-axis, notice that I have labeled the y-axis as y instead of f of x. Hence, the arc of the function can be labeled as y equal f of x. Now, to identify the domain is the horizontal extent of the graph that takes any values of x in a real number system except x equal 0. So the domain is written as, in interval form, round bracket negative infinity to 0, or the union symbol represent or from 0 to infinity. 0 is not included. Or in set form, the domain is x such that x takes any value in the real number system, but x cannot be 0. The range of the function is the vertical extent of the graph that takes any value of y in R, except y equal 0. Hence, the range can be written as from negative infinity to 0 round bracket, or from 0 to infinity round brackets, or in set form for all values of y in a real number system R and y cannot be 0. In the next example, we need to find the domain and range of the function gx, whose graph is shown below. Here we have a rational function graph. Observe that there are two asymptotes. That is x equal 4, the vertical asymptote, and y equal negative 1, the horizontal asymptote. Thus, our function gx is not defined for x equal 4 and y equal negative 1. Thus, the horizontal extent of the graph takes any values of x in the real number system R except x equal 4, and so the domain is written as from negative infinity to 4, or from 4 to infinity in interval form. 4 is not included, or in set form, the domain of G is for all x in R, x cannot be 4. The vertical extent of the graph takes any values of y in the real number system R, except y equals negative 1. So the range is from negative infinity to negative 1, or from negative 1 to infinity in the interval form, or in the set form for all y in R, y cannot be negative 1. In this example, we have an absolute value function graph. Observe that the graph extends horizontally from negative 3 to 3. But negative 3 is not inclusive, since the small circle is unshaded. But 3 is inclusive, since the small circle is shaded. Thus, the domain of f is the horizontal extent that takes the values of x from negative 3 to 3, and can be written as, in interval form, round bracket negative 3 to 3 square bracket. Square brackets indicating that 3 is included, round bracket indicating that negative 3 is not included. Or the domain in set form is from x, which is greater than negative 3 but less than equal 3. Meanwhile, the graph extends vertically from negative 1 to 2 inclusive. Thus, the range of f is written as, in interval form, square bracket negative 1 2, or in set form f of x such that f of x is greater equal negative 1 or less than equal to. Here we are given the graph of a root function y equals square root x plus 4. So since it is a root function, the value under a square root side must always be positive. Thus, this is possible for values of x greater equal negative 4. Thus, the domain of y extends from negative 4 onwards. Hence, the domain is written as in interval form negative 4 to infinity, where negative 4 is included, hence the square bracket, or in set form x such that x greater equal negative 4. Notice that the value of y is from 0 onwards. So the range is written as in interval form the square bracket 0 to infinity, or in set form y such that y greater equal 0. For the last example, sketch the graph of the piecewise defined function gx equal x plus 2 for all x less than 1, gx equal 2 over x for all x greater equal 1, hence state the domain and range of the function. For the piecewise function, the curve is drawn piece by piece based on the values of x given. Firstly, draw the axis, the x-axis and the y-axis labeled as gx. Now, for all x less than 1, the function is a straight line graph gx equal x plus 2. Observe that when x equal 1, g1 is 3, and the point 1, 3 is not included. For the values of x greater equal 1, the graph 2 over x is drawn, and observe that at x equal 1, g1 equal 2, and the point 1, 2 is included. Thus, the horizontal extent covers for all values of x. Thus, the domain is for all x in R. In interval form, we simply write domain is R, or in set form, domain is x such that x belongs in R. While the vertical extent is from infinite value until the maximum value of gx, which is 3. So the range of value of gx is less than 3, and is written as from negative infinity to 3 round bracket, or in set form gx is less than 3. Let's summarize today's lesson. Domain is all the possible x values of a function. In other words, the domain is all the inputs of a function shown on the x-axis. And when looking at the graph, the domain is all the values of the graph from left to right. The range is all the possible y values of a function. In other words, the range is all the outputs of a function shown on the y-axis. When looking at the graph, the range is all the values of the graph from down to up. Okay, that's about all for now. Thank you for watching. Hope the lesson was beneficial for all. Please subscribe to my channel to receive notification of my next video lesson. Thank you and bye for now.